Hello, we are discussing about GATE 1992 ECE paper and the topic we are discussing is electronic devices. This is 7th one mark question came in 1992. Look at the diagram. If the transistors in figure have high values of beta and a VBE of 0.65 volts, the current I flowing through 2 kilo ohm resistance will be dash A 1 milliampere, B 2 milliamperes, C 3 milliamperes, D 4 milliamperes. The transistors are having high value of beta and a VB of 0.65. We need to calculate the current flowing through 2 kilo ohm resistor. The correct option for this one is A 1 milliampere. We see the details now. This is the diagram given and the information related to this one is VBE 0.65 volts and beta is very large. Whenever beta is very large, normally we used to calculate base current using this relation. Base current IB is equal to IC by beta for common emitter. IC by beta, beta is very large, so that is going to be giving the very small value which can be approximated as 0. So IB is equal to 0. Whenever IB is equal to 0, we can say that one IE is equal to IC, because emitter current is sum of base and collector currents. But if the value of beta is very large, at that time base current can be neglected. By that time we can assume emitter current is simply same as collector current. So whenever the beta is very large is given, the conclusion is nothing but you can neglect the base current. So whenever beta is very high, simply neglect the base current and emitter current is same as collector current. If you look at this diagram, this is collector of Q1 transistor, it is emitter of Q1. Emitter of Q1 is nothing but collector of Q2, and collector of Q2 is nothing but it is same current flows through this emitter of Q2. Let us assume current flowing through this 2 kilo ohms is I, that is the collector current of this transistor. Since beta is very high, same current flows through this emitter, and emitter of first transistor is same as collector of second transistor, so the same I flows through this collector of second transistor. Since beta of this transistor is also high, same I is also flows through this emitter of second transistor, so the I is also flows through this 1 kilo ohm. So current flowing through 2 kilo ohms is same as current flowing through 1 kilo ohm. If you calculate the current flowing through 1 kilo ohm, that itself is sufficient, which is the answer for the current flowing through 2 kilo ohms. So this is the conclusion you can get. Current flowing through 2 kilo ohms is nothing but collector current of Q1 transistor, that is first transistor, which is nothing but emitter of Q1 transistor because beta is very high for that transistor, which is nothing but collector of second transistor, and which is equal to emitter of second transistor because beta is very high, and emitter of second transistor is nothing but current flowing through 1 kilo ohm. So simply current flowing through 1 kilo ohm is nothing but current flowing through 2 kilo ohms. So now we will calculate current flowing through 1 kilo ohm resistor, that is the answer required. Okay, so this is I. Since base current flowing through the transistors is 0, so 10 volts is going to be applying across these three resistors. As no current is flowing through this bases, by that time the current coming from this 10 volts is going through all these three resistors. So all these three resistors are in series. We can use voltage division rule to calculate voltage drop across this base of second transistor, that is nothing but this point, that is voltage drop across 1.65 kilo ohms. Base of second transistor VB2 is nothing but this point, that you can calculate it as using voltage division 1.65 divided by total resistance, that is 1.65 plus 1.85 plus 6.5 into total voltage 10 volts. So VB2 is given as 1.65 volts. We can calculate. Now draw the equivalent circuit across Q2. This is Q2 transistor whose base is connected at 1.65 volts. So 1.65 volts, we are replacing this one. The voltage across B2 is 1.65 volts and it is connected, emitter is connected to 1 kilo ohm. We are interested in current flowing through 1 kilo ohm. Now apply KVL across Q2 transistor. KVL across base to emitter loop of Q2 transistor. So that you can write it as 1.65 minus VBE minus I into 1 kilo ohm. So VBE is given as 0.65. So I of 1 kilo ohm is nothing but 1 volt. I is equal to 1 milliampere. So current flowing through 1 kilo ohm is nothing but current flowing through 2 kilo ohms. So the required answer is nothing but 1 milliampere. The correct option for the question is A, 1 milliampere. Thank you.